The Miss Miller's Math Show, where we have our great host, Miss Miller, and her assistant, Bristow.
Alright, more enthusiasm today. That's true. Oops, okay, one thing at a time. Bah. Okay. Alright, here we go. So everybody's all hyped up because tonight we have our awesome rec night with video games and movies and s'more cake pops and pizza and popcorn and Jamba Juice and Hunger Games. It's going to be fun. I hope I see you all there. Okay, so here we go. You all have an advantage as well. Because I am the one that is selling tickets, you can come up after we do our notes and buy tickets. There you go. You don't even have to wait till lunch. Okay. Okay, so here's what we're doing today. We are looking at more multiplication of radicals. So let's just kind of get right into it. Basically, the rule that we want to follow here is that you can multiply everything underneath the radicals together and everything outside of the radicals together. So we're going to distribute, on the first one, we're going to distribute like we normally do. And again, everything that's underneath the radicals gets multiplied together and everything outside gets multiplied together. So, in this first one, it's like there's an invisible 1 here. So 1 root 2 times 5 root 3. Yeah, Brandon? No, I know. I don't know how I ended up writing. It should be 3 root 7. Look at it over here. It's more normal on that side. It's 3 root 7. Okay, 1 root 2 times 5 root 3. Alyssa? Okay, so let's do, so if we do the outsides first, 1 times 5 is? 5. Okay, and root 2 times root 3 is? Root 6. Good. Okay, everybody give it up for Alyssa.
Woo, Alyssa.
Okay, so again, you multiply everything outside of the radicals together and everything underneath the radicals together. So let's try that with the second one. We have 1 root 2 times 3 root 7. Can somebody tell me what they think that is? Aiden. Excellent. Everybody give it up for Aiden. Okay, we're going to take a pause. Oh, that's, okay, good. We don't need to take a pause. Okay. Now, you always want to go back and make sure that you have simplified fully. If we were to go through and try simplifying this, that's what we would end up getting. 2 and 3 and 2 and 7. Can't do much with it, so this is our answer. All right, move on to the next one. Root 3 times root 2 plus root 3. Distribute. Somebody tell me when I distribute what I get. Sloan. Good. Excellent. Everybody give it up for Sloan. Hey. And Samantha. Which is what? Excellent. Everybody give it up for Samantha. Now, I can just add these together. Root 6 plus 3 is 3 root 6, right? Why not? Why not? Why can't you do that? Thane. Exactly. Very nicely put. Everybody give it up for Thane. So, and let me reiterate what he said. He said if we got 3 root 6, that would mean that we're multiplying them together. Remember, we have to have like radicals in order to add them. If this had a root 6 on it, then we could add them to get 1 root 6 plus 3 root 6 is 4 root 6, but we can't. We're just going to leave it like that. How are we doing on questions? Okay. Let's move on then. 5 plus root 2 times 5 minus root 2. Okay. Think back to last semester since I know you all loved it so much. I'm a little bit sarcastic. Okay, so if we had something last semester like x plus 2 in parentheses times x plus 5, how would I go about multiplying that? Zach?
You would do
Excellent! Everybody give it up for Zach! Yay. You have made everybody everybody's day, by the way. We have to FOIL or box. So, F-O-I-L. Let's write this out so we can see where this comes from. We'll do FOIL on the first one, and if you guys want to do box on the second one, we'll do that. All right, so if we're multiplying the first ones together, 5 times 5 is, everybody? 25. Yeah. Apparently, Aiden is everybody. Yeah. Yay. Okay. Outside, 5 times negative root 2 is? Excellent, excellent. How about the inner ones? Root 2 times 5. Alyssa. Excellent. Everybody give it up for Alyssa. And the last ones, positive root 2 times negative root 2, Alyssa. Negative root 4. Everybody give it up for Alyssa. Yay! Okay, now, does anybody see anything that we can either simplify or that we can combine or anything? I'm going to get Sloan and then Alan.
Okay, so the negative 5 root 2 and the positive 5 root 2, don't they just like boom, cancel out?
They do. They boom, cancel out. Yes, nicely done. Everybody give it up for Sloan. Yeah. Alan, did you have another thing that you saw? What's the square root of 4? 2. Everybody give it up for Alan. So we're left with 25 minus 2, which everybody, what is 25 minus 2? 23. I better not have heard 24 back there. Okay. Questions? How we doing on questions?
No, ma'am.
Okay, so far? Cool. Let's do one more of these, and then we're going to move to our last type of problem. I know how much you all love this stuff, so this is another gift to you. Okay, this one we have root 5 plus 2 root 6 times 3 root 5 minus root 6. Okay, do you guys want to do FOIL or the box? FOIL. Okay, I'm hearing lots of foiling again. So let's see. What did I do? I used the orange one. Let's keep consistent. First, outer, inner, last. So F-O-I-L, F-O-I-L. All right, so somebody start me out with the first ones. Root 5 times 3 root 5. Somebody tell me what that equals. Root 5 times 3 root 5. Thane.
That would be, wouldn't that cancel 5 because it's root 5 times root 5?
Exactly. So I'm going to wait to do that so people can see where it comes from. You're totally right. But you're getting 5 because 5 times 5 is 25, right? And the square root of 25 is 5. Good. Excellent. Everybody give it up for Thane.
Yay, Thane.
3 root 25, and he jumped ahead a little bit and said, but the square root of 25 is 5, and then 3 times 5 is 15. I'm going to do that in a few steps. Nicely done. Okay, outside. Root 5 times negative root 6. What do we think? Aiden.
Negative root 30.
Negative root 30. Everybody give it up for Aiden.
Yay.
Okay, inside we have 2 root 6 times 3 root 5. Cole. 6 root 30. Everybody give it up for Cole.
Yay.
Okay, last we have 2 root 6 times negative root 6. What does that one come out to? 2 root 6 times negative root 6. Alyssa?
Negative 2 root 36.
Cool, everybody give it up for Alyssa. All right, we want to do the same thing that we did on the last problem. We want to see if there are like radicals to combine, if there's anything that can be simplified. I'm going to now do what Thane was mentioning before, which is say that the square root of 25 is 5. So this becomes 3 times 5 or 15. Okay, does anybody see anything else that can be done? Sloan.
36.
Good, everybody give it up for Sloan. The square root of 36 is 6, and then negative 2 times 6 is negative 12. All right, anything else that people see that can be done up here? Alyssa?
The negative root 30 and the plus 6 root 30, the root 30 cancel out and the 6 becomes a 5 because there's an imaginary negative 1.
Okay, good. So negative, excellent. Everybody give it up for Alyssa. Okay, let me reiterate what she said. Negative 1 root 30 plus 6 root 30 is 5 root 30. So remember, they don't actually cancel out. No. It's like saying if I have $6 to start out with, and Kara takes one of those dollars away, I'm left with how many dollars? $5. It's not like I'm left with nothing. I'm left with $5. Makes sense. Okay. Then we combine 15 and negative 12 to get 3. So it's 3 plus 5 root 30.
Yay!
Yay, the end. Everybody give yourselves a round of applause.
Yeah.
You do want to make sure that none of these can be reduced, but if we think about breaking 30 up, 30 is 6 times 5, and 6 is 3 times 2, and we don't end up with any pairs of anything, so we are done. Okay. We have 3 more problems left, and then we're done for today. Oh, Lorenzo's upset. We can do more if you want.
Yeah.
Okay. Next set of problems. Okay. In this, you see the instructions say rationalize the denominator. What that means is mathematicians have spent many, many, many hours and beyond coming up with these wonderful math rules that maybe don't make sense to any of us, but we have to follow them anyway. One of these rules is that we can't have radicals in the denominator of a fraction. So, we have to do something to this fraction with a radical in the denominator so that the denominator no longer has a radical. Anybody have any ideas? We're going to multiply, I'll just put this here. We're going to multiply by something over something. Go! Root 5 over, not 3, because then it would all just cancel out. It has to be the same thing on the top and the bottom. Everybody give it up for Colt.
Yeah.
Now, why are we doing that? Let's see what happens when we multiply this through. Vanessa?
Well, on the bottom, we get root 25.
Excellent. Everybody give it up for Vanessa.
Yay.
So she said, when we multiply the bottom, we get the square root of 25, which is 5. Okay, what do we get on the top? Is it radical 15? 3 root 5. Good. Okay, so you can see that by multiplying by the square root of 5 again, we end up getting the square root of 25 and no longer have a radical because there is a perfect square root of 25. Are there questions?
No, ma'am.
Okay, let's do another one of those that's a teeny bit different so that you all can see. Okay, the cubic root of 7 over the cubic root of 2. Okay, if we were to follow the same approach that we did on the last one, what would we be multiplying by here? Somebody tell me what they think we'd be multiplying by. Zach? Cool. Everybody give it up for Zach.
Yeah.
Okay, now before we multiply this through, if we do this, the cubic root of 2 times the cubic root of 2 is the cubic root of how much? What's 2 times 2? 4. Is there a perfect cubic root of 4? No. Is there something else we might be able to do so that we do have a perfect cubic root? Not? Excellent. Everybody give it up for Tyler. He was right. He said we multiply it 2 times. Why are we doing that? So he's totally right. Somebody explain to me why we would have to do that in this case. We only had to multiply it once on this one because of something. Liz? Exactly. Everybody give it up for Liz.
Yeah.
Liz said, so for the camera that probably didn't pick that up, she said, we're looking for a cubic root. Well, if it's a cubic root, we need 3 of them in order to have a perfect cube, right? Make sense?
Sure.
If there are questions, now's a good time to ask. It does make sense? Okay. So on the top, 7 times 2 is?
14.
And 14 times 2 is? 28. So the cubic root of 28. On the bottom, 2 times 2 times 2? 8. And everybody, whoops, what is the cubic root of 8? 2. There we go. All right, everybody give yourselves a round of applause. Yeah, what?
What is the point of doing
Because the goal is to get the radical out of the denominator.
Is this ever gonna? Are we ever gonna get a number on the top that can be simplified?
You might. And then you can reduce the numbers on the outside, yeah. Sometimes that'll happen. Not in these examples, but sometimes it does. Other questions? Last one.
Ooh, yes.
And with this last one, same set of directions, it says rationalize the denominator. And I want to refer back to, so everybody write this down, 5 over root 3 minus root 7. I want to refer back to something that we did a little bit ago, so you guys can maybe make some sort of conclusion from it. So we want to get, rationalizing the denominator again means we're getting rid of the radicals that are in the denominator, okay? Meaning we don't want any radicals anymore. So we did 2 examples earlier that had multiplication of binomials like this. Okay, so in this first one, we multiplied 5 plus root 2 and 5 minus root 2, and what did we end up with as an answer? What did we end up with as an answer? 23. Is there a radical in that answer anywhere? No. Okay, the other one, we ended up multiplying 2 completely different things. Root 5 plus 2 root 6 and 3 root 5 minus root 6, and we ended up with a radical again. So if we look at this first example, 5 plus root 2, 5 minus root 2, does anybody see a way that we might be able to apply that same concept to this so that we get the radicals out of the denominators? What do you guys notice about those? Michael? Excellent. Everybody give it up for Michael.
Yay.
So how many people noticed that about these? That everything is the same except the sign between them is different. You guys see that?
Yeah.
Okay, that's what we're doing here. The denominator is root 3 minus root 7. So let's try and see if root 3 plus root 7 will be something that gets rid of radicals for us. So on the top we're going to distribute, and on the bottom we have to FOIL. Okay, so on the top, 5 times root 3 is 5 root 3. 5 times root 7 is 5 root 7. I'm going to go through and FOIL this kind of quickly. Root 3 times root 3 is root 9. That's the first. The outside is positive root 3 times positive root 7 is positive root 21. Inside, negative root 7 and negative root 7 and root 3 is negative root 21. And then the last, we have negative root 49. So simplifying this, root 21, negative root 21 go away. Everybody, what's the square root of 9? 3. What is the square root of 49? 7. Okay, 3 minus 7 is what? Negative 4. So you guys tell me, did we end up getting the radical out of the denominator using Michael's approach?
Yes.
Yes, we did. All right, give yourselves a round of applause. That was All right. We are done with notes. Are there questions? No, everybody is ready to be done. All right, send us off. It's Friday. It's Friday.